Welcome to our 5th lesson. In this lesson, we'll teach you how to use the sound sensor. What is the sound sensor? A sound sensor is a sensor that can detect sound. For example, clapping, or hitting your fingers, or just shouting. It cannot detect exactly what you're saying or what kind of noise is it, but it's activated by any kind of high frequency sound. So you can do clapping, you can do finger hitting, anything you want, it can detect. So how it works? We have 3 pins, G and D, VCC, which is negative and positive pins, and also GPIO 18. All this controlled by the CrowPi. We only need to remember that it's controlled by GPIO 18. So we will control GPIO 18 to send out input signal from the sound sensor, and then we know when sound happening. We get input. Also, we have this screwdriver place. We will use it to configure the sensitivity of the sensor. If you want it to be more sensitive or less sensitive, it's up to you. You can configure it right on the board, and I will show you how. So remember, GPIO 18 as input and the sensitivity regulator to regulate the sensitivity of the sensor. Let's see how we're going to do it. Alright, we're back to our CrowPi board. Let's take a look at the sensor. The sound sensor is right here, the black thing. And this is the sensitivity regulator. It's all controlled by GPIO 18, and there is no need to modify the switches to make it work. How do we regulate the sensitivity? With every CrowPi, we will attach a screwdriver. You can use that screwdriver to modify the regularity, the sensitivity, by turning it right or left and testing it with your code. You won't know if it's enough until you test your code, and then you will know. So, especially here, I already regulated the sensitivity, so there is no requirement to change it right now. Let's go into our code and see how it works. We go into our CrowPi folder and find the sound file, sound.py. Then we open it with the IDE. After opening it, let's go line by line and see how it works. So as we already know, we import the GPIO library and the time library. Afterwards, we set the sound pin into GPIO 18, which is the GPIO that controls the sound sensor. Then we set the mode to GPIO board, not GPIO BCM, which is also available. Then we set up the sound pin as GPIO in, because we get input from outside. Then we set up pull up down GPIO PUD up, which is very important. This action will let the GPIO know that the action is not to keep it working all the time, but just when you hear the sound and then release it afterwards. It can prevent some bugs from happening. Later we run a try loop, which will try to do the following command until keyboard interrupted. And when keyboard interrupted, we will clean up the GPIO to make it available for the next files to run. Then, if GPIO input sound pin is GPIO low, which should be high, but our CrowPi board is not the same as all the modules because the complexity of it, so we'll use GPIO low. So if the input is low, then the sound is detected. Else, don't do anything. So basically, when the sound is detected, we will print in the console that sound is detected. And then we will wait 10 milliseconds to continue. So, let's try it and see what's going on. The console is right here, so we should be able to see the sound detected output here in the shell. So let's run it and see the results. As you can see, it says sound detected. If I speak not so loudly, it cannot hear me. But if I raise my voice, as you can see, it will write sound detected everywhere. Let's try it again, maybe with a clap this time. As you can see, it's working perfectly. What you can do with this? Let's see, probably you can control the relay. When you clap once, it will turn on the relay. When you clap twice, it will turn off the relay. You can control the fan or maybe LED. We hope to see what you can do with this sound sensor next time, and hope to see you in our next lesson. Thank you for watching.